this panel, I think we're beating the dead horse at this point. All of this facilitates competitive advantage. As I quoted the former CIO of Walmart, Roland Ford, it is the only competitive advantage that we as enterprises have over each other. Real quick, when it comes to continuous delivery, I wanted to spend one slide before we get onto our esteemed panelists, just to talk about kind of at a high level what continuous delivery is, and the wrapping up in terms of CI. We talked about deployment, and now we're talking about delivery. And really, it's all about there's some sort of system that facilitates builds. This is probably your CI system. And then builds themselves are verified in some way. We talked about testing, whether it be automated testing, unit testing, integration testing. And then at some point, there is some sort of component of a canary. And implicit in every step after a build is there some sort of deployment into some environment, whether it be staging, QA, production. And the verification could be one level. And then canarying, again, is a more of advanced form of testing. But Gap talked about it. A number of companies are embarking on a canary strategy. And then finally, it's live. And at the end of the day, continuous delivery facilitates that competitive advantage with a pipeline that can get software from inception into in the hands or in front of your users rapidly and with a high degree of confidence.
What I'm going to talk about is, and what I face on a daily basis, is how do you transform a large organization? We have over 1,300 applications. This is a company a few decades old. The joke is, we don't have mainframe, but we have IE6. The dig on Microsoft people here. And then, we need to, these are critical to keeping the business running. And you can't stop and say, we want to do this big CI initiative or CD initiative and stop doing what we're doing. And pretty much we need to figure out how to incorporate it while keeping the business running. Also, we have a large workforce to retrain and transform. In Intel IT, we have over 6,000 employees supporting a company of over 100,000 employees. And many of the developers don't know test-driven development. This is opposite of what you're trained to do for the last 20, 30 years, is write your test first before you write the code. And also, there's this mention of the huge cognitive load. If you're not thinking about continuous integration, automating your tests, you pretty much have your code and your IDE, you're ready to go. With continuous delivery pipeline, all of a sudden you need to learn this 20 other tools. So how do you do that, on a large scale? And additionally, with QA, with the existing QA force, how do you transform somebody who is used to just doing manual testing to more developer skill set where you're architecting and developing automated tests? And finally, the culture aspect. I myself personally have a lot of challenge selling continuous delivery. People are scared about the conversation. It's like Jeff said. You mean you want me to take what I spend my weekend 24/7 with this huge launch call doing more frequently? No thanks. So we have to be a little bit more creative in selling the message that hey, this is about what about zero downtime deployment? Do you care about that? What about increasing the confidence or your definition of done? So we have to be a little bit more creative. So let's talk about the solution space. So this is a simplistic diagram of our approach, strategy, and plan. So we've found that this is something we evolved over a 2 years period. In order to address this in a large scale successfully, you need to look at this you need to address this 4 quadrant, which is technology, governance aspect, the practice, and the culture. On the technology aspect, we found that it's important to make it easy, and again, to reduce that cognitive load. The more that we can provide the service, packaged together, taking care of the integration, the less the development team have to figure out how to stitch all these, these pieces together. And especially big challenge of, all the open source technology, how do you stitch everything together? So again, we found that making that easy is the BK. It's the best known method for us in transformation. The other aspect we really needed to address head on is this governance. Because we found that we have teams that are just doing continuous delivery, but then up to deployment to production, and then it just languish while you need to get approval from 10 different cabs or technology committee or whatever else you need to go through. So where we had good acceptance is we start approaching those CAB and the technology committee, and I myself run one of such committee, so I'm part of the bureaucracy, is that, hey, we should automate it. We should automate the governance so that if some bare minimum policy in place, so that if they're all green, this can become a carrots and stick, where if the developer are doing the right thing and you codify your policies and codify policies telling they're doing the right thing, then they should be able to release as frequently as they want to without getting in the way. So this has a positive impact in both, raising the bar on the development team to get on this continuous delivery path, to automate more of the tasks, increasing the quality, and at the same time, letting the governance body be able to achieve 100% compliance, because it's really hard to do 100% compliance if you make everybody come to you. And then the culture aspect, we have to address the workforce transformation and service delivery transformation. So some of the retraining challenges I mentioned earlier. So with that, we just basically start seeding the knowledge everywhere. We have a community of practice. We start offering, vendors offering training, and as well as hackathon to try to get the knowledge out there. And finally, the practice aspect, we're seeing there's a lot of misperception that, hey, just because I'm using Jenkins, I'm using a CI tool, or I'm using Selenium, I'm therefore doing continuous integration. So as I think Jess and others mentioned earlier, continuous integration, continuous delivery is a very rigorous engineering practice. And we find that people have trouble getting started. So we ended up doing is we developed this maturity model where we let team evaluate where they are currently and figure out, what is the one or two things they can do next week or the next month, whether it's just automating the build, whether it's just automating a build and then writing one test, and then build from there. So that's kind of our approach. And the idea is what we found is, is this iterative process for us to be able to find the right system in place, between the governance and the technology stack in place, to be able to reinforce the right behavior.
Vice President of Technology at the Cloud Foundry Foundation. So you've heard Cloud Foundry mentioned a couple of times. Spinnaker integrates with it. You heard the story from Gap. That technology was donated by Pivotal to a industry association, which is who I work for. And so now we have Pivotal, VMware, EMC, IBM, SAP, a whole bunch of other, about 50 of them, companies that actually collaborate on it. So that's where I'm from. But before that, I've only really been in what you could call the product space for about 2 years. I spent 18 years in the world of being a developer, in the world of being an operator, both within IT departments as well as within lines of business, right? So I've kind of lived the problem that we've been talking about, not from a product guy trying to say, hey, look, this is the solution, but I've actually lived the problem in that trying to run a team and get them to do continual integration and all that. That said, we are a little bit focused on kind of what are the challenges that line of business developers have in application architecture, how can platforms support that? So that's what I'm going to focus on today. And really, I think there are 4 challenges that I'm going to talk about and some of the solutions that I think apply to them. The first one is that, frankly, designing apps to be loosely coupled with your environment is hard. Your vendors probably aren't doing it. How many people have purchased software that has some wacky requirement about like the hard drive spindle speed? Everybody's got that running around. It's hard to do, and it's a big kind of mental change for both your teams, your developers, as well as your vendors. The second is that moving from people-based deployment to the fully automated mechanism, we've been talking about this throughout the day today. Most organizations still have that situation when they go to roll to production that they need to call Sally because she's got to do the load balancer change so that you could do your blue-green deployment, right? This is very, very common today. Really, really difficult to make the transition. Third, application owners data is a big problem for an application owner. and being tightly coupled to your database is has continued to be the way that a developer thinks about things. So newer technologies like NoSQL or taking a evolutionary approach to schema design or even immutable schema, those are all great potential solutions, but they're hard to accomplish. And then last, man, we do a lot of configuration management in this industry, but every single team probably has their own part of the configuration of production. Whether you're talking about operations or whether you're talking about platform operations or the firewall guys and then the software engineers and then, the application ops team. We've got configuration management scattered all over the place. So I see those as really four of the problems that app teams have to deal with. One of the solutions that's kind of emerged in the industry is this pattern called a 12-factor application. Has anyone heard of this before? Raise your hand if you have. Yeah, a few folks have. Rightfully, this should be credited to Adam, who had worked at Heroku at the time, and a number of the Heroku engineers. Heroku has been acquired by Salesforce.com, and they're a platform as a service. But they did really spend time thinking about what are the characteristics of an application that best runs in a PaaS environment. And there's 12 of them, right? But they sort of summarized into the 5 bullets here. The first one's that you're using declarative formats to describe your automation, your dependencies. You're being declarative, you're not scripting. Second, very clean contract with the underlying operating system, to the point that you really don't care as a developer what operating system you're running on. If you care, you're probably making a mistake. The platform should handle that for you. Third, you need to actually deploy on modern cloud platforms, right? We've been talking about Google and their more servers than God. That's real, and they're offering those servers to you. Walmart has an enormous cloud environment that they're working with. And they need to also be able to work with public cloud providers. So you need to be able to deploy on these modern platforms. Next, minimize divergence. Dev, test, staging, production should be identical with one difference: the scale and perhaps the data that you're actually working with. But you really, really need to minimize your divergence there. Now, on the flip side, that's the way a developer needs to think about their application. On the flip side, it's possible for applications. It could be something like Cloud Foundry or OpenShift, or it could be something that Netflix has built. Everybody's kind of solving for this problem so that you can create an environment for a 12-factor app to live in. Those platforms need to deal with the declarative syntax for the deployment requirements of the apps. They need to be able to deal with taking code and getting it into a running form somehow. Dealing with multiple infrastructure environments that you could run on or target for provisioning. You need to deal with multiple versions of the application, support blue-green or canary node deployments. And then last, you have to make it really, really easy to both horizontally and vertically scale any app instance that's out there. So that's our perspective on one of the approaches that app dev teams can use to think about architecture and that operations teams can use to think about how do you support as a service provider the application teams that are out there.
I'm first excited to be here and talk about a lot of things open source. I loved hearing all the enthusiasm both from the panelists and people in the room adopting open source. It's clearly near and dear to my heart. My background is coming from spending a lot of time in open source communities doing software development. And one of the things I found is we're adopting some of the patterns that we developed in open source development across the industry into how do you provide your internal products and continuously potentially deliver and even deploy those development efforts into your runtime environments. Now, my experience is that I'll kind of break this down in terms of some challenges into two main categories. And the lines are blurry, so don't take those too literal. And that's on the developer side and on the IT operations side. On the developer side, my experience is that developers are lazy in a good way. They don't like any kind of obstacle, again, in a good way. So this is all the creative energy that we're trying to harness in building our products together. And so some examples of where your process can get in the way includes the actual application architecture that you're building and defining for what you're trying to put into production. So a large monolithic application has historically some forms of efficiency. You have a single maybe source code repository for the entire tree. But as you move to a continuous integration and continuous delivery model, that thing becomes a behemoth. It's a beast. Moving it from stage to stage in a pipeline is fundamentally slow. Potentially, the internal complexities of a single change means you're going to, as a single developer, introduce a change that may stall a number of other developers, and you really don't want your developers sitting there stalled out waiting for something to happen. So this is certainly a change. We're moving in the industry away from these large monolithic applications, but they're not going to go away. So one question is, how do we integrate those and sort of isolate those portions of your aggregate application that are still monoliths from slowing down the rest of your developers? So in that context, because gates or this continuous integration, continuous delivery pipeline, there's various stages of validation. And because those various stages are directly impacting a developer's workflow, it's important to think of that as, in my opinion, think of that as kind of a continuum. It's actually something that needs constant attention, focus, and even development around. And that is, what types of testing do you do at what stage in the pipeline? And certainly, the earliest stages in the pipeline, you want to do very light testing because the developer's needing immediate feedback. If you have a 24-hour return cycle on your you push a commit and you wait to see any results, nothing valuable is going to come of that. I'm pretty confident in that. You'll have developers off finding ways to get around that system, which is what you're really trying to avoid. You're trying to bring developers together and have a consistent way of producing your applications. So to me, the important thing is you've got unit testing, you've got functional testing, you've got systems tests, integration tests, all these tests. Putting those in the right stage in your pipeline is important, and understanding that that's a kind of a living part of your organization, and that the exact positions of those tests, the makeup of those tests are going to change over time. Well, we talked a little bit earlier about test-driven design, and that's a buzzword that is it's just as a buzzword, it can be off-putting just a whole class of developers. So I think it's worth thinking about not the exact buzzword, but the process that you're trying to achieve, and introducing the notion that quality is critical from a developer point of view, testing is important from a developer point of view, and internally, Red Hat, we did something as simple as change our QA team to the QE team. They're the quality engineering team, and really focusing on the fact that everybody's an engineer involved in the process, something that we've talked about already a few times today. So it's great that we're all seeing some of the same things. As you create this production pipeline, and you're creating these sort of consistent ways to push code through the pipeline, the more you insulate the environment that your application is running in, you're potentially introducing a barrier to your developer, and that barrier is, how do I get inside and debug a real problem? So some of this can be solved externally with telemetry and getting rich logging information and metrics out of your application. Some of this is just making sure that a developer has all the automation necessary to recreate an environment and actually go in and do sort of deep developer level debugging that's critical to solving some of the bugs that will pop up when you're doing testing and validation. On the IT operations side, and this is actually a blurred line, we talked already about how do you introduce change into your production environment. And when you have a big distributed system, your change may introduce incompatible backwards changes in database schemas. You have potential incompatibilities in your APIs. So how do you manage versioned APIs? How do you manage rolling forward, recognizing that you may create a problem for other components in the system, and being able to potentially roll back, or as some earlier today described that as continuing to roll forward, and that's introducing a fix to the bug that you've introduced quickly. These are really critical concerns, and they're actually, in certain cases, made more complicated by the fact that we're slowly breaking these applications apart from a large monolithic application into independent pieces. One of the observations that I've found valuable there is, the more complex the system is, the more automation is critical. And this is where we talked about dependency management and understanding what portions of your service are potentially causing dependencies or potentially rippling effects to other services. And these are things that are automatable. You can manage this with tools. And humans are going to be inefficient at managing these really big, large, complex dependencies. In the pipeline, we're talking about many organizations that have a long history of being risk averse, and for very valid reasons. You're living in regulated industries, and you've developed great rigor around change management and process for how do you make fundamental changes in your business. We can't just throw those away, but we do need to introduce innovation. We need to introduce a culture of embracing risk and understanding what the guardrails are around that risk. And so some simple things I think Sherry brought up earlier, some simple things that you can do is just incorporate your existing change management process into the CI/CD pipeline that you're trying to build so you can more rapidly deliver your applications. And another piece that we've seen, this has popped up in a number of different projects that we've worked on, everything is version controlled. It's not just the code, it's your configuration management. It's even something as simple as the job that you're running in Jenkins, using templates, checking in the job description into a revision control system so that you don't manually go in and change the job description in Jenkins and break something and really have no history of what happened, no way to roll it back. Nobody really understands, there's no clear way to continue to evolve that and move that forward. And specifically, other developers who may need to be involved also need to create these similar types of environments for their own version of a pipeline. So templating and consistent definition of your pipeline, I think, is really important. So one thing I wanted to just put forth is we've been talking about all these technologies together today and yesterday, and it represents massive evolution in the industry. I break it down into these sort of 4 categories: development process, application architecture, deployment or packaging, and your underlying infrastructure. We're talking really exclusively at the bottom of this chart. We're talking about DevOps, microservices, containers, and cloud. And it's the combination of these 4 things, this confluence of really fundamental changes in the industry that are making continuous integration and continuous delivery or even continuous deployment fundamentally possible. It's all about speed and agility, and that speed and agility comes from automation. Automation is not possible if you're racking and stacking gear with people, and each of these individual components bring efficiency to the system. They're not strictly dependent on one another, so you can. There's a progression. You can move from where you are now to that very bottom part of the row, the very bottom row, without going all in one step.